Hello, everybody. Welcome to the very last installment of our vibe coding and statistics practice for this class. We're going to have some other videos in the future about data processing, but this is the very last one where we're going to just be doing basic coding for different types of statistics. And this one is going to focus on our two types of chi-squared analysis, chi-squared goodness of fit and chi-squared tests of independence. Now we'll go over the details of exactly what the differences are between those types of analyses and what chi-squared generally is evaluating. But big picture, chi-squared analyses are evaluating categorical variables. So variables that can occur in a variety of states, but are not numeric, can't be measured, can't be counted. So things like, as you can see on my screen, whether or not you own a dog and what knowledge group you would be classified into for a disease, for example, in this case, alpha-gal. Now, what chi-squared analysis is going to do is take counts of individuals that fit into each of those different categories and then evaluate potential trends in that count data. Now, there are two different ways that chi-squared analysis does this, and we'll talk about our first one, chi-squared goodness of fit. In chi-squared goodness of fit, you've got a single categorical variable, so for example, dog ownership, and what you're doing in that case is testing whether or not the distribution of responses in that variable vary either from a neutral distribution, 50-50, or from an expected distribution. So the way that we're going to test that out on this data set that I've got pulled up for you here is using our dog owner variable. In that dog owner variable that I've got highlighted with my cursor there, the options were yes or no. And so we're imagining that individuals took this survey and they were asked whether or not they had a dog. Now, with chi-squared goodness of fit, we can say, does my distribution of dog ownership differ from what I would expect given the general population's distribution of dog ownership? So let's say I took this survey of people living in Columbus and I surveyed, let me see how many are in this. I surveyed 68 individuals, right? What I want to know is, did I get a representative portion of dog owners, or do I have a weirdly large number of dog owners or a weirdly small number of dog owners relative to what I would expect given, let's say, the US population norm? That's what chi-squared goodness of fit is going to tell me. So let's go ahead and get started with that chi-squared goodness of fit. Okay, so first things first, whenever we're doing coding in R, we always want to set our working directory. And I know you won't be able to see this, but I'm going to hide my floating meeting control so I can see. And again, setting your working directory is really easy. You're just going to click on that session button, go down to set working directory, and then click choose directory. And from there, it's just going to pull up your files. I'm already in documents, which is where my working directory is. I'm going to scroll down, click R directory, and hit open. And just like that, now in the bottom right here, you can see that I've got my working directory set to my R directory. Okay. So then the next thing that I want to do is read in my data set. So what I'm going to do is go ahead and click over to my R directory. There we go. And now I'm going to find it, which I want to say I saved it as video. So that's going to be down here. And remember, I've given you this trick before where I always just straight up copy and paste the name straight from my file system so that I can't goof up any capitalization, any spelling errors, anything like that, so that I can make sure that when I give R that code to read in my data, it is exactly correct. Now, we've done this a whole bunch of times before with vibe coding, but I'm just going to go ahead and do it again. And again, you can use whatever chatbot you want. And I'm just going to say, I have already set my working directory to read in R. I have a file named, and then I'm just going to give it the exact name, and I'm going to add CSV so it knows it's a comma separated value folder. I have a file named that, write code to read it into R. All right. And now ChatGPT is going to think about it for a second, and voila, it's going to give me that code. Now, remember, you can just highlight and copy and paste if you want, but in the case of ChatGPT and a lot of these chatbots, it'll give you a handy dandy little button over here that you can just click copy. All right, so now we're going to head over into R and we're going to copy and paste that in that upper left-hand pane, and we're going to make sure that it reads in okay, and if it doesn't, we'll debug it. All right, looks like it read it in just fine. And that looks the way I would expect it to, right? I've got my dog owner column and my alpha-gal knowledge column. Okay, now like we said for this first analysis, we want to do a chi-squared goodness of fit test to find out if our proportion of dog owners in the survey matches the expected proportion from the general population. So at this point, we can ask ourselves, all right, how do I get that expected proportion of the general population? Well, if you have no way to know what the expected proportion is, typically we just evaluate versus a 50-50 distribution. But we can do a little bit of Googling and find out what proportion of Americans actually do have dogs. So what I did was a quick Google, and then I went over to the American Veterinary Medical Association, a nice trusted source, and I'm looking at this table here that has statistics about dogs and cats. So percentage of U.S. households owning dogs, 42.6%. Okay. So now I know what I expect to see, and I can evaluate that against what I actually see in my data. So let's talk a little bit about how we're going to get R to give us the code that we need to run that chi-squared goodness of fit test to find out whether or not our proportion of dogs that we observe in that survey matches what we would expect from the American population at large. Okay. So a lot of the same rules that we've already talked about in vibe coding apply to this same example. Remember that we said it's always critical to tell the names of our variables, the options for our variables if they're categorical, the exact statistic that we want it to run, and of course the program that we want it to write that code for. Okay, so let's think a little bit about what we want to tell R. So we're going to tell R that the variable we're interested in is the dog, or excuse me, not R, tell ChatGPT or your chatbot of choice. So we're going to tell our chatbot that the variable we're interested in is dog owner. And I'm just going to copy and paste that so that I don't have to worry about any potential typos. So I'm going to head over to R and I'm going to tell it I have a variable named, and I'm going to give it that exact name with two options, yes and no. I want to run a sorry for the typos, squared goodness of fit test for this variable. Now, like we said with chi-squared, we're running that evaluation against an expected distribution. Now, right now, ChatGPT or whatever your chatbot is has no way of knowing what that expected distribution is. So we've got to tell it that. So let's go over to our pet ownership, and I'm just going to copy and paste this. Okay. I want to compare against an expected distribution of, and I'm just going to copy and paste that, 42.6% yes, as in yes has a dog. And so what would that be? 43, that's 57.4. 57.4% no. Okay. Write code for this analysis in R. All right, now let's hit enter and see what happens. All right, so it's giving me all of the different steps. I've got my expected, I've got create a frequency table, run the chi-squared goodness of fit, and like our chatbot has said, that's it. This is a really straightforward analysis. So let's go ahead and copy and paste over this table of observed frequencies, so just tallying up our yeses and nos. So I'm going to copy and paste that straight over into R. I'm going to hit run. It made the table, and now I can see it. I have 36 no's and 32 yeses. Okay, so now let's see what the chatbot told me to do next. Next step was to actually run the chi-squared goodness of fit test. So let's go ahead and copy that over, head over into R to actually run that code. And just like that, we're already done. So this is a really straightforward, pretty darn fast analysis, honestly, quite a bit less complicated than a lot of the ones we've already done. Now, real quick, just to make sure we're all on the same page with what this is giving us, let's take a look at the output that R has provided for us. So down here, we've got a couple different things. One is what looks like x squared. That's just because x is the closest regular letter that we have to the Greek chi. So our chi-squared statistic is 2.9739 on 1 degree of freedom. We're not going to really worry too much about degrees of freedom, but for goodness of fit tests, it's just the number of options you had, in our case 2, yes or no, -1. So we had 1 degree of freedom. And then the term that we're really interested in, as usual, is this guy over here, our p-value. That p-value of 0.08462 is greater than our standard cutoff of 0.05. So that tells us that the deviation of yeses and nos that we saw for dog ownership doesn't differ significantly from what we would expect from the general American populace. So that tells us that the sample that we took is representative of the broader population with respect to the proportion that do or do not own dogs. Okay, so that's our first chi-square statistic that we want to go over. But now we're going to go ahead and talk about our second, which is chi-squared test of independence. And we're going to really quickly head back over to our data set so that we can get an idea of the way that we're going to use this test of independence. So for our second chi-squared analysis type, our test of independence, what that statistic evaluates is whether or not two categorical variables are significantly related to one another. So in this example, we already figured out our dog ownership column. Yes or no, you either are a dog owner or you're not a dog owner. But then the second categorical variable that we're going to look at is a respondent's knowledge of alpha-gal. Now, we haven't talked about alpha-gal in class, but alpha-gal is a tick-borne illness, primarily spread through the Lone Star tick, that is really problematic, really challenging, where if an individual develops alpha-gal syndrome, they develop potentially life-threatening allergies, primarily to proteins involved in meat products, and it can be very difficult to assess whether or not an individual has alpha-gal syndrome until an allergic reaction event to one of those products happens. So in this case, in this imaginary survey that I've made up for you all, we're going to be asking whether or not dog owners have a higher or lower knowledge of alpha-gal compared with non-dog owners. Now, we might expect that perhaps dog owners will have a higher average knowledge of alpha-gal because they're out more walking with their dog and they're engaged in regular tick prevention with that dog. But that's exactly what our chi-squared test of independence is going to evaluate. Does dog ownership impact alpha-gal knowledge, or technically vice versa? But of course, we wouldn't expect alpha-gal knowledge to impact dog ownership. Okay, so for alpha-gal knowledge, we've got two different categories that individuals could fall into, and that is a high knowledge of alpha-gal or a low knowledge of alpha-gal. And you'll see that we've got some dog owner yes individuals with a corresponding high knowledge of alpha-gal. We've got some individuals who own dogs with a low knowledge of alpha-gal. And then same thing for our no dog owner individuals. Some individuals who don't own dogs do have a high knowledge of alpha-gal. Some individuals who don't own dogs also have a low knowledge of alpha-gal. So we've got individuals with every possible combination of these two variables. Okay, so now let's talk about how we're going to figure out whether or not these variables are related to one another. All right, so let's go ahead and head back over to our chatbot after we get the column headers so that we can tell our chatbot exactly the variables we want. Now, one thing that I did not do intentionally when I initially made this example is I actually have a typo in my second variable column, alpha-gal knowledge. So that L comes after the E instead of before it where it should. This is one area where having that copy and paste trick to make sure that you're telling the chatbot exactly what your variable names are is really handy. Because instead of going in and fixing that typo, now that I've discovered it, it doesn't really matter. I would change that typo before I presented it in any situation. The only reason it would really matter is if I don't convey that information to my chatbot, and then the chatbot produces code for a correctly spelled variable name. But if we copy and paste, we take care of all of that. Okay, so same exact deal here where we always want to tell the chatbot the test that we're doing, the names of our variables, the options for those variables, and the program that we're running that test in. So I'm going to tell my chatbot here, I want to run a chi-squared test of independence. My variables are titled, and I'm just going to copy and paste dog owner and alpha-gal knowledge. The options for dog, I'm actually going to copy and paste it so I don't confuse the chat bot. For dog owner, copy and paste are yes and no. The options for, and I'm going to copy and paste this again to not confuse the bot, alpha-gal knowledge, there we go. Alpha-gal knowledge are high and low. Okay, write code for this analysis in R. Now, in this case, I don't have to look up any expected values for the proportion of dog owners or the proportion of people in the general population who have high or low alpha-gal knowledge. Because remember, with our test of independence, I'm not comparing my variables against a prior set expected distribution. Rather, I'm asking if the proportion of high or low alpha-gal knowledge varies as a product of that yes or no response. So I'm asking about that internal relationship between my two variables rather than whether or not either of my variables corresponds to some expected distribution from an outside source. Okay, so let's go ahead and enter. All right, here's the code to run a chi-squared test of independence in R using your variables. And it tells me what variables I've given it. It tells me the different categories for those variables. And now it's going to give me that code that I need to run the test. So again, I'm just going to hover my mouse over that copy button in my chat bot. And I'm going to hit copy and then head over to R and paste that right in. Now, since I'm using the same data file as the previous analysis, you'll notice I didn't have to read in a new data file because it was all contained in just that same file. Okay, so let's go ahead and run this data, created the table, and now it shows me the table. That table says for high alpha-gal knowledge and low alpha-gal knowledge, here are the number of no's and the number of yeses. Okay, so the number of no dog owners and the number of yes dog owners and how their corresponding knowledge of alpha-gal tracked out, whether they had high knowledge or low knowledge. Okay, so now let's head over and get the next portion of our code. Step 2, run the chi-squared test of independence. So I'm going to copy that code over from my chatbot and head over into R, and then we're going to run that code. Okay, so voila, just like that, we're done. Like I said, chi-squared tests are pretty darn straightforward, but again, let's go ahead and go over this output that I've just highlighted for you to make sure that we're all on the same page. So this output looks more or less the same as the output from our previous chi-squared analysis. We've got this value titled x squared. Again, that's our chi-squared statistic, in this case 11.334. We've got our degrees of freedom, and critically for us, for our interpretation, we've got our p-value. Now in this case, that p-value is very small, p of 0.000, yep, 307612, obviously way below our 0.05 cutoff for significance. So what this tells us is that we do have a significant relationship between our variables. The probability of high or low knowledge of alpha-gal syndrome is affected by whether or not an individual is or is not a dog owner. And when we just generally take a look at that distribution from the table that I'm hovering my cursor over now, we can see how that distribution of dog ownership, yes versus no, related to that high versus low knowledge of alpha-gal. For individuals that did own a dog, and I've just highlighted that row in my table there in the bottom left for you, we see that about 2/3 of the individuals had a high knowledge of alpha-gal. When we look at individuals who are not dog owners, the trend is the opposite, in that far more individuals had a low knowledge of alpha-gal than had high knowledge. So this would suggest to us that individuals that own dogs are generally more knowledgeable about alpha-gal syndrome, and we could investigate the specific mechanisms for why and whether or not that's potentially because of the tick prevention that they're involved in, or whether the information is coming from veterinarians and things like that. But that chi-square test of independence let us evaluate whether or not those two categorical variables were or were not significantly related. Okay, so that finishes up all of the coding work that we need to do our two different types of chi-squared analysis. Some parting notes for you all before I sign off here. In these videos that we've been working on with vibe coding, one of the things that I've mentioned quite a few times now that makes chatbots such a nice tool for building out these coding skills is that the chatbots are flexible. So that means when I'm typing out my prompts for those chatbots, you absolutely do not have to use the same words that I use specifically, right? The content is what we're going for here. So the way that you phrase that, the way you enter in that information, that can vary because those chatbots are quite flexible in their ability to produce outputs based on the content of the prompt you've provided. So don't feel like you need to copy and paste over my words exactly. I mean, you see me chatting with that chatbot live on these videos. I'm just typing as I go. I'm not working off of a script or anything like that. And that sort of flexibility is something that you'll also want to work to build your comfort in. So don't try to phrase it exactly the way I do, just focus on the content of those prompts. Okay, so now that we've worked through this guided video in using R and chatbots to do chi-squared analyses, both goodness of fit and tests of independence, what you're going to do now is head back over into Carmen, find that next data set, and then do this exact same sort of analysis independently. All right, so thanks in advance for watching this video. Hopefully it was helpful to you, and I will see you all in class.